a cell phone, for example. You can put all the thinking, the imagination you have in the cell phone, but then you sell it, and the user will use that any way they like. Right? So you design a system, and the user will put in all sorts of different input. You never know. So the thing as a designer, you want to make a kind of safety, maybe not just for the user, but for you too, is you want to guarantee that if they put, the thing you want to guarantee, if they put something okay here, nothing, well, at least something okay coming out here. Alright, so that's the thing. So maybe more formally, this one here is BIBO if given that Mxn is less than if this thing here is all of this number are finite. So I have everything finite. Something is bounded. Then the output also finite. Right? So that is a stability that we can guarantee. So that if I have a okay signal coming in here, I don't want to burn my chip. Right? Or if this thing blow up, like in computer, it can give you the overfloating number. Right? An overfloating number can have a very deadly effect. So you all know the story about one of these very expensive spaceship sent up. I think it's number 4 from Europe, right? From what is that? Area. So they sent inside that. So they spent about $1 billion. They sent a big satellite up and then blow right away up the center. And the only single problem on that is they use an old chip, and when they do the computation, the chip, the number get overflows, right? So it just completely corrupt the system, and then it sends the spaceship something wrong, and then explodes. So $1 billion can be thrown away in a seconds, if the system is not stable. So that, and you never know, right? You have a cell phone, it might burn the chip, or give you something not intelligent outside. So the system is like this. The system is like that. And let's put a theorem here. I should say, not this thing here. I should say, for any input coming in that having this, we have, right? That is the stamp I can put on this system, BIBO system. Yeah. The stamp I put in is, if you put something bounded inside, I guarantee the output also bounded, right? And that for any, that's the keyword for any. So the theorem to say here is an LTI with the HN, here, HN is unipose response, is BIBO or stable, right? In the single processing, stable means BIBO stable. Okay. If and only if the summation of Hn less than infinity. Something I showed you earlier on. I give you, but now maybe we need to show that. Okay? Alright. So that is talking about these systems here. So we need to prove this. Okay. We have proved this. So maybe I'm going to do one side and then take the other side. So if I'm going to do maybe the if part, and then to do in a homework exercise the only if part, so later. So if I have if summation on Hn is less than infinity, right? If this thing here is less than infinity, then for any bounded input xn, assuming that where the absolute value of xn, if this thing here is finite, that means I can always find a number that everything has to be loaded. Okay, so where this thing here less than some big constant n. Okay, you agree that these are the two things are the same, right? So finite, that means I can find a number whether we have, from here we have that the y output here equal to the summation. Now I can use a convolution theorem. I can use convolution theorem and taking this hk times x of n minus k, k running here, and I take the absolute value. I have this absolute value. The sum of the absolute is less than the absolute of the x sums. Sorry. So absolute of the sum is less than or equal to the sum of the absolute, right? So this is less than or equal to the summation of hk times x of n minus k. But now each of this is less than some number n. So that would less than or equal to some number n outside, multiplied with the summation of h. Okay? And this is a finite. So this is also less than some infinite number. Okay. Is that clear and all? Alright. So if I have the summation is finite, then I'm guaranteed that the system is stable. Okay, so I'm guaranteed that the system is stable. And if the system is stable, then I let you as exercise to show that this thing has to be infinite. And the trick is just constructing some signal that is finite, and also checking that this output also finite. And you got this. Okay. So the only if as an exercise. Okay. Alright, so we do see the system now, the Z domain, and C may be the example. Remember the systems. I have a system H, and is equal to a to the power of n u of n. Right? That is systems. And we can use the Z transform, and we know that the S of Z is equal to Z over Z minus A. I did that early on, where the R of